All right. My name is Michael Dimovich, and the design pattern I'm going to be talking about is MVC. Here's an outline of the presentation. I talk about a summary of MVC, the intent of the design pattern, the motivations for using it, how you can apply it, the structure of the pattern itself, the participants, the collaborations, the advantages and the trade-offs, the implementation and the known use, and related patterns. And I also have a demo application that I built using an MVC framework. It's like a basic blog content management system application. All right, MVC is a architectural design pattern, and it was initially designed for implementing user interfaces for software applications. The application is divided into three major interconnected sections, each handling a specific facet of the program. The goal of this is to separate internal representations of information from the information that is presented to the user. The intent of MVC is to decouple major parts of an application into their own encapsulated sections. Basically, the model, the view, and the controller of MVC are all separated into their own either classes or file structure, and this allows you to reuse any of those components without having to change the other two. So if you wanted to change the view, you wouldn't have to change the controller and the model as well. This allows for pretty efficient code reuse and parallel development with multiple developers working on the same project. So the motivation behind MVC was initially to separate the background logic of software from what the user sees. Basically, it was initially designed for user interface use to separate everything, all the calculations and stuff and everything going to the database from the presentation layer. Another motivation of MVC is if you want to be able to see the same data with multiple different views simultaneously. Like say you have data in a database that you want to see both a graph and a chart simultaneously side by side. These can both be accomplished with MVC. MVC separates the database model, the user interface, and the controller. And the controller acts as an intermediary between the model and view. Each of these components are kept separate, and the model and view never directly interact with each other. Basically, this keeps each section of the application encapsulated, and it's hiding any irrelevant details in the logic from the user. And like I said before, each of these components is kept completely separate, so you can reuse them or change them without having to change the others. The applicability of MVC has changed in recent years. When it was first designed in the 70s, it was used as a method for separating logic from user interfaces. And in recent years, a lot of big companies have co-opted MVC and have begun using it for developing web applications. In this version of MVC, the view acts as a web page output, the model interacts with the web database and the logic, and the controller handles URL routing, and will basically tell the user tells the program which views to show the user, and will also accept user input and send that to the model. The major structural aspect of MVC is the separation of models, views, and controllers into their own components. And basically, the model, the view, and the controller are each either in their own class or their own file structure, and they are kept completely separate, and there are no overlapping between the three. And basically, the view is used specifically for output display purposes. In the case of web applications, usually in the form of HTML, CSS, and JavaScript. The model handles the database and any logic that interacts with the database. The controller acts as an intermediary between the model and view, and it describes how the model handles responses from the view. So keeping each of these separate helps to solve a general design problem, which is being able to change any one of the components without having to let the others know. And here, this is an example of an MVC file structure implemented in Python using the Django framework. Basically, the model and view are stored in the models.py and the views.py Python scripts. And additionally, the output formatting files are stored in this templates directory. The controller portion of the app is stored in the urls.py script. And these are basically the main three crucial components of an MVC application. The participants, as we just talked about, are the model, the view, and the controller. The model is the central component of the pattern. The model manages the data, logic, and rules of the app, and any data-related logic the user works with is handled by the model. The other thing that I forgot to mention here is the model is what interacts with the database, and it creates all of your database views, and in the case of Django, it actually generates the SQL queries for you. The view handles how data from the model is represented in the user interface. So any user interface components are managed by the view. This would include templates, scripts, images, style sheets, HTML pages. You can also have multiple views of the same data, and depending on the user's request or response, you can change the view. An example would be a graph or a chart displaying the same information. And the controller handles input requests from the user and converts those requests into processes for the model or view to handle. The controller acts as an interface between the model and view, since the model and view never directly interact with each other. The controller in web development, if you're developing a web application, usually handles all of the URL routing and will handle basically what pages the user sees when they go to specific URLs. The collaborations are the model and view only interact with each other through the controller. They never actually directly interact. The model sends data to the controller, which is then shown to the user by the view. And then additionally, the controller accepts user input and user responses from the view, which allows the user to interact with and manipulate data in the model without seeing the details of the model. So the controller basically it acts not only as a routing tool to send users to the right place, but it also acts as a intermediary for the model to interact with the model without displaying the logic and behind it. Some of the advantages of MVC are efficient code reuse and low coupling, and because of this, pieces can be really easily changed without having to change other components. So if you want to change your view or your model without changing your controller, that's possible with MVC. MVC can also be used to rapidly develop application prototypes. Since the file structure for MVC is pretty much designed for you, it doesn't take much to get an app up and running with a MVC. It's actually very easy to get a decently designed prototype up relatively quick. Another advantage is that MVC supports multiple views for a single model simultaneously, which is really useful for data and for displaying data. You can see it in many different forms all at once. Some of the trade-offs you deal with MVC are that MVC is a complex architectural pattern, and it can be difficult to understand, especially with certain frameworks. I know in the past that I've worked with, the file structure is pretty robust in some MVC frameworks, and that can be confusing at first and overwhelming. And also, if you're only working on a small project, it can obfuscate your code and basically make it harder to read. You basically need to know when and when not to apply MVC, and you should apply it when you're building a intermediate to large size web application. Also, the developer must have knowledge of multiple different technologies to fully take advantage of MVC. Since MVC deals with both the front end and the back end of a web application, You need to be able to use it to its fullest extent. You need to be able to do both parts, or have multiple programmers working on the same project, with one doing front end and the other doing back end. So the implementation of MVC, the main purpose is to separate the logical structure, the user interface, and the interface that is used to interact between the model and view. And this is implemented, at least in Django, by storing each of them in their own class. And so each model is implemented as a class, which describes the data and the logic behind the data. This also has all of the database tables, and any information that relates to the database is handled by the model. And the controller routes URLs to the proper location and ensures right views are being displayed by to the user. In a web application, the controller also processes GET and POST requests and then talks to the database to get the information the user requests. The view is usually implemented with front-end formatting languages such as HTML or CSS, and it displays information from the model routed through the controller to the view. And this is an example of a model class for a blog. Basically, the class models what the table in the database is. And in this specific example, using Django, when you run the server, you do what is called a migration. And basically, it takes all of these classes from the model and generates the tables for you. So in this case, this would generate a table that has a title, a body text field, and a date time field. Also, this operator overloaded here, it will display a list of all of the posts, of all the titles. These are some examples of controllers. The top controller is the main controller for the entire project itself, and the bottom controller is the controller specifically for the blog aspect of the application. And what's interesting about Django is Django implements URL routing using regular expressions. So in the bottom framework you can see, or in the bottom picture you can see here, basically this is a regular expression for grabbing, letting the controller know that each of the pages of the blog posts are all ending with their primary key. And so essentially what this does is it allows you to dynamically create new pages without having to go in and manually create new templates every single time. It'll use just a single blog post template, and it will know that depending on the primary key that you enter, it will it'll send you to the proper post. And here's an example of the review. In this situation, each of these functions represents a single page of the application, and what they do is they actually return renders, and they return and then those renders return the HTML pages. The reason we use renders instead of just directly inputting HTML pages is because inside these HTML pages are a templating engine code from a language called Jinja, and basically that allows you to dynamically create sections of HTML without having to manually go in and change things. The known uses of MVC, that's pretty much up until recent years, MVC was used primarily for user interface design, basically separating the components of the interface from the background logic of the program itself. But recently, with the internet, a lot of large companies have co-opted MVC to use in frameworks. Some examples of these are Laravel, Django, Rails, or ASP.NET MVC, and these are all used to develop like full-fledged web applications. Also, iOS and Objective-C were built heavily using MVC. there's some related patterns. The probably the closest related patterns to MVC are the offshoot patterns that mimic the overall structure of the projects, but change just some minor details. One of these is MTV, which stands for Model Template View, and Model Template View can actually be implemented in Django as well, using the templating engine. The relationship between the controller and the view is an example of the strategy design pattern. And basically, this means an object that represents an algorithm. So essentially what the strategy design pattern does is it creates a family of related algorithms and lets them vary interdependently. So you don't you can substitute one for the other. The overall structure of MVC's separation of components is an example of the observer design pattern, where each of the different components are observing what is happening from the other components without actually being tied to them. Other design pattern methods that are closely related to MVC are factory, decorator, and composite. So for this presentation, I built a personal website and blog demo, which I implemented in Python using Django framework. The blog posts are tied to a database, and the URL of each blog post is dynamically created using regular expressions, and the database is primary key of the post. So if I exit out of this, I'll start with the code. Here is one of the views. So basically, this goes through and renders all the template pages to display output for the user. And as you can see here, you can dynamically add things into the view. So basically, I have a template page with a couple like open spots using Jinja, and I'm filling in those spots in Python with these variables. All right, now here is the main application's controller. As you can see, it's using regular expressions to format each of these URLs, and basically it's saying any page that starts with admin, use the admin controller. Any page that starts with web app, use the web app controller, and any blog page, use the blog controllers. So the blog controller, let's see here. Here it is. This is where I have this regular expression to dynamically create the pages, the blog post pages, using the primary key of the from the database. And basically, what this is doing is it's appending this to the end of the URL that was initially used in the main controller, which is /blog. So anything, it'll be blog / then the primary key of the post, and by typing that in, it will directly automatically route you to the page that post corresponds to. And all of these posts are use the same basic template. Now the model. This is the model of the blog posts, and basically you have a title and a character field, and you can set the max length. You can add different attributes, and basically what this is doing when I migrate the database, it's creating SQL code that will generate all of this in SQL and push it to the database. So let's look at the application. So here's the application server running, and let's see here. So if we go here, this will take us to the admin page of the application, but I want to go to the main page. Okay, so here's the main page. I just have some dummy text in there right now, and I have a little simple layout using Bootstrap. Now here's the blog posts, and this is what's pretty interesting about it is, as you can see here, the primary key for the post, since there's only one post, is 1. and since that it appends that to the URL, and the program automatically knows to do that. And now if I were to go into the admin page and make a new blog post, let's see here. Now, if I wanted to, I could go to 2. And now I have that new post. And all the posts are listed here. That's actually what this function here is for. It's so I can list all the posts out just with their titles. And I have a simple contact page. But basically, in this text here, this is all generated dynamically. As you can see in the views here, I have these contact strings, and then I have a basic template that I use for just things that need simple plain text. And I could add multiple versions of this page that all do different things, and change the text of the page by using variables without having to change the whole page. And so let's see here. Other than MVC files, that's about it. That's the main gist of MVC. Is you're separating the models, the views, and the controllers, and basically you're creating a system where each of those components are acting independently, and it allows a lot of freedom to freely change things without having to worry too much about what's going on in the rest of the program. You can run into issues when you get into bigger applications, but that's more of a matter of the programmers on your team. So thank you for watching my presentation, and I'm Michael Dimovich, and I'll see you later.